morning, ladies and gentlemen. Today, from the part of India, we are about to present me on behalf of my team. I would be showing you one of the latest state-of-the-art projects that my institute has taken up and which is soon expected to go national, maybe by this month end. So we have not named it yet. As of now, we call it by our institute name, the Indian Institute of Technology, Hyderabad, SSB. So what is our mission? What is our vision and what are the deliverables? So what we want to do is whenever a natural disaster happens, one of the biggest things that goes down is the communications infrastructure. Recently it has happened with Nepal, and whenever an earthquake occurs, it does happen at parts of India as well. Or for that matter, recently there was huge floods. There were huge floods in some parts of India, and one of the first things that came down was the communications. And once only the communications was established, only then the aid followed in a very quick way. So what we want to do precisely is we want to take the complete telecom infrastructure that exists on ground, especially in India, into space at an affordable cost. And we want to do it with small satellites. So that's the main key takeaway for us. So what we want to do is we want to have a constellation of clusters covering the Indian subcontinent 24/7. So before we go into that step, one of the biggest things that we need to demonstrate is the intercluster and the intra-cluster communications. So that's what is the main goal of the complete project. So these are the specifications that we are going forward. So there is no 100% rationale for this. Because we have decided for small satellites, we want to fix the weight around about 20 to 25 kilos. And followed by the proper like size dimensions. And one of the important aspects is plan A that we are currently working on is for a laser communication. So for that we need a very high accuracy of 1.2 milliradians. So if you see the color codes, most of the innovation comes into attitude determination and control systems and payloads, because formation flight has been something that has not been tested in a full scale in space, number one. And number two, for one of the clusters, we are planning to have membrane optics, which essentially works on the principle of diffractive optics, wherein currently in the world when we see it's only the US Air Force Academy that's pursuing these kinds of optics. So why do we want to look into membrane optics and all of it? I'll just tell in a minute. And communications and onboard data handling, I would say partly innovative, and the structures and electrical power systems are standard that we are going by. So what do we want to do? We want to have a hybrid architecture for it, wherein only when they are on India, we want to have them in a very tight formation, and once they are out of India, we want to just ensure that the drift is minimal, or the drift doesn't go beyond the specified ranges, and for that, the behavioral approach is quite good. And as you know, the virtual structure, we want to have it, we treat the formation as single rigid body, and when it comes to the behavioral architecture, we want to see that they avoid collisions. So that's one of the main important stuff for that. And for membrane optics, as I've told you, this comes from something that we have learned in our school, basically, the Fresnel zone plates and photon sieves that at most of the schools they are taught in +1 and +2. They work on diffraction, but the only thing is, why hasn't diffraction been tested? Yes, the efficiency of it is low, but at the same time, it offers a lot of size and mass advantages that when we have looked into. So that's one of the places wherein we can look into for good amount of innovation to come in. So yeah, this is the one wherein I want my complete cluster to maintain the communication link between the payload, satellite, base station, satellite, and in between the satellites as well. And it needs to transfer the data regarding the position and health of each satellite. So these two are the very critical functions if I were to ensure that my complete communication systems works really well. Apart from that, the other important thing is the handoff mechanisms, especially for from the communications point of view, need to be worked out very well. And one of the important hurdles for that is to properly ensure that my Doppler effect is put into my communication architecture. And at the same time, we are trying to develop an in-house made protocol for the complete communications. Thank you very much.
Thank you very much. So we have a little extra time. Some questions? Please raise your hands. Okay, thank you. Go change the next presenter.